influencers say. So what are the different use cases? Again, this can be a huge set. I have covered a very small set here, but each of them I will go into a little bit detail because it will trigger some thoughts in your domain, what you can do, what you can put on a thinking hat in your domain, and which can help you in approximately kind of thinking in your direction. So let's start with games. Today, there are several gaming companies who use machine learning in a big way for multiple things. First and foremost, they look at what is known as fraud detection. Interesting thing, what is fraud about? It's about people trying to cheat the game by either collaborating unethically or trying to hack it into different steps, and sometimes this causes revenue loss for some of these gaming companies who base their entire you know business model on how much people come and spend. Or if you're talking about game experience improvement itself, that itself can be another use case for using big data. What does game experience improvement mean? Game experience improvement means, suppose people, you find that they're crashing out at specific step in a game. That's something which can be a feeler to the designer, saying that maybe there is this new way to invent around or give more options at some specific game. So that's a very interesting area, because I put that as the first because today there is a huge amount of analytics and machine learning being done on the behavior of people who play games and use that to improve ergonomics, usability, etc. for the games, detect fraud, etc. Next, let's come to computer vision. Computer vision is a broad area which is responsible for identifying how you can simulate the notion of human eye, where you see objects, recognize objects. It's used in several domains. The most important usage is in robotics. What is robotics usage? Robotics usage is about navigation of a path. Let's assume that a robot is left by itself and it has to navigate a whole house from one room to another. So that's where computer vision algorithms come in. They try to look at input to its camera from the front, try to look at how it can infer something is an obstacle, and then try to explore alternative paths. This it does by experiencing over several instances, and if sufficient number of instances are generated, you can assume that the autonomous nature of the interaction can kick in with a certain high level of confidence, where even without explicitly taking an image at that point and inferring, it can automatically traverse from one room to another without being guided by the camera itself, just by looking at its location, because of the historical data that's been fed into it and the model that it's created with a machine. That's path avoidance is one example. Let's take other example. Let's take, if we were to train a robot to do a specific task. Let's assume if we were to train there are several categories of robots, right? Let's take a humanoid robot. Humanoid is something which tries to be more on the gentle side, which are supposed to be aids to humans. A humanoid robot being taught on, say, a specific set of nursery rhymes to play with a kid. That if you teach it several times, I'm sure it is going to pick up on its own, and depending on the kid it's working with, it will appropriately decide which nursery rhyme to pick up and start. So think about it, a humanoid. Let's think about a scenario where we're talking about not necessarily robotics. Let's take a vision application. I'm sure all of you have seen that in Facebook there is nowadays a feature by which if you have tons of pictures already uploaded and tagged with specific person, it auto tags people. How does it happen? It happens because of vision. This is basically it understands from the visual images and the correlation to name or the specific person identity on a web page or the Facebook page, and does this over historical occurrences of web pages or Facebook pages and creates enough intelligence such that it can do without any human intervention an automatic tagging of people just by looking at different varieties of images. It could be low light, it could be different angles, but still it's able to do this tagging. That's a classic example of vision. Moving on, autonomous vehicles. This is again a very important, very important area where machine learning is useful. Why it is useful for autonomous vehicles? Let's take an example of today, of course, all companies, whether it's General Motors or Honda or all, but Google was the one who started this autonomous vehicle. What are the use cases for autonomous vehicle to use machine learning? Very simple. Let's take example of path avoidance where there is high traffic. So it is possible that just by looking at the density of traffic in a specific path, I'm sure that given the intelligence in the Google car, it will be able to navigate alternate routes. Or let's take example of what is the ideal distance it should keep from the nearest car for avoiding. This is a classic example of machine learning where you try to see typically from past experience what has been the distance between the car in the front and car in the back and try to create a balance. Some of it could be manually fed rules which govern this, but those rules can always be improvised by it learning over the millions of miles it has run. Next, very important is crash avoidance. Let's assume that you are in a scenario where you're approaching very closely your nearest car. So that should trigger a reaction, right? So that is where the input signals that is being sent to the camera should trigger an alert saying that there's something which is like an accident scenario, and then that should trigger a avoidance scenario. That is action which can take. So in all of this, if you see, there is this element of, there is a raw sensory input, there is an intelligence which is the historical data being fed to some model that is created, and that model is used to create an action or to response. So it is very much a response to the raw input driven by the model which is generated by your machine learning. That is the basic principle in all of these cases. In one case, it was about identifying a path. In another case, it was about taking action in case of accident. In another case, it was about taking an alternative path. All kinds of examples we have. Let's do a speech recognition. Today, I'm sure there are several examples of software which do automatic recognition of what you're speaking. Siri, Google Now, classic examples. What does it do? It's basically looking at history of matching the voice tones to syllables to collection of syllables forming the words, speech grammars, and using the historical analysis of speech of a specific person, just like face tagging, we can even do speech tagging here by identifying who is speaking in a specific input of a raw data of a speech. There are several other examples of speech recognition using machine learning. Example of recognizing someone is just one of them. Like recognizing which language somebody is speaking, for example, is a very good example. Or how do you marry speech recognition to a transaction which you're doing? Can we use speech recognition to bypass some steps in your transaction? That can, let's take an example like we have a way to navigate in your Google Maps to a specific location. So what does Google now or a Siri do if you say I want take me to some place? It bypasses some multiple steps which you have already done, like translating the speech into search words and search words matching to some location on the GIS or on the map of Google, and then converting that to a directions or a routine set of directions from the point where you are to there. So if you see, all of these multiple steps are bypassed by taking an approach to using all this historical data and learning from the past data, plus putting into right engines which can translate your raw data into actionable grammars, etc. Similarly, moving on to language recognition, this is very useful, especially in case where you want to do machine translation. I'm sure Google Translate a lot of our people use. Today, people are also trying to marry image to Google Translate. For example, if you give a camera of a, say, a Spanish road signal, it automatically takes it and converts it into a English signal and then passes on to underlying Google Maps and maybe use that to help you navigate through the new area. Classic example of language recognition is also in when you have large corpora of text, say historical text or large storybooks or large novels, you want to translate it to a new language. There, you try to create a model by which you can translate this whole thing into a new language. Yeah, yeah. So I was actually coming to OCR example for classifying a document in the IT service automation, but classic example exactly. So example of language detection is there also. An example of detection of features in a document. Let's take in a document having say an item code, an invoice code, a address. All of that today can be automatically detected, and we can actually convert that to appropriate category of the document, or even I would say we do one more step further, which is we automate in the sense that if data from that particular document was typically done by a BPO agent filled into another form, online form. In fact, that's a huge industry in BPO where we take the raw data from a original invoice or a purchase order, put that data back into online forms. In fact, that's a huge order management uh, back office processing. It's a very important revenue dimension for BPO industry. Diagnostics is a very generic word. I will use that in several scenarios. Let's take example today. People are very gung-ho about Watson, IBM Watson, right? IBM Watson is this large mega machine learning machine which is developed by IBM, which actually resolved a lot of historical data related to knowledge, artifacts, etc., and won the game of Jeopardy against the world champion of Jeopardy. What was it doing? It was basically converting all the historical knowledge to something known as being able to find correlations, being able to find causative relationship between objects. So what is diagnosis? Diagnosis is basically a very simple request. It is basically identifying potential cause having observed certain effects. You see that in several industries, in several scenarios, you see that there is a cause effect relationship. It could be that there are multiple causes for a specific effect. Most common example is healthcare. You have, suppose, running nose, right? A running nose could be because of a common cold, or it could be because of a fever, or it could be because of something more dangerous. It could be a bird flu, H1N1, or something like that, right? So what does diagnostics do? Diagnostics allows you to create relative probability of a certain cause having observed certain effect. So that's what this does. This helps us in diagnostics. What we try to use is we try to use underlying technology, which is like abduction systems or machine learning systems based on recommendation engines, which allow you to identify potential root causes of a certain observed behavior. Very useful in healthcare. In retail, it is useful in specifically when you are trying to identify why certain shopping cart categories are being dropped more often. In case of manufacturing, etc., diagnostics is very useful when you want to get into this whole notion of maintenance. What is maintenance in manufacturing? It's about what we typically call as either a scheduled maintenance of your equipment. It could be your aircraft engine, it could be your aircraft, it could be your lathe machine, it could be your pipeline, it could be your drilling machine, all kinds of machinery in the industry. They usually have scheduled maintenance. It could be, for example, a rail coach. What they do is at scheduled intervals, they perform overall look at what is the vital statistics. Is the oil level right? Is the filters working properly? Is the fluid right? Is the current supply coming proper? Is there a wear and tear of that? Can you measure that? So they do a scheduled maintenance. But then if you see machine learning driven approach using diagnostics, what people try to see is, can we try to create looking at the faults which are generated, which is basically defects in the manufacturing or faults which are observed in the field, and then see how they have been repaired in the past. What are the root causes? If you create a large database of historical analysis of the root causes of faults or repair scenarios, that can be used to that can be a great use case for improving the effectiveness of how you carry out diagnosis. The diagnostics in this scenario is about moving the whole paradigm of maintenance from what we call as scheduled maintenance or reactive maintenance, which is reacting in response to a fault or a breakdown, to a preventive maintenance, which is preventive maintenance is about taking a proactive approach to potential faults that may arise by looking at a historical data on what could have been avoided by taking a proactive approach to solving some of the causes or handling some of the causes. So this actually is causing a whole new dimension to this whole manufacturing across several sectors. Is auto, high-tech manufacturing, aero sector, and all of this whole notion of maintenance is taking a new approach by combining it with Internet of Things, where Internet of Things is actually allowing fine-grained data to be collected from all of this industrial equipment and sent to centralized machine learning centers where they can diagnose all of this, look at historical data, marry that, and come up with proactive approach to handling faults, handling repair scenarios, etc. So as we speak, there's already a huge buzz in manufacturing industry on how we can use IoT plus machine learning as an approach to revolutionize how we maintain our equipment, how we maintain heavy duty equipment like huge drilling machines, huge pipelines, huge robotic machines, huge assembly line machines, etc. So I think people who are interested in looking at making a career in machine learning, a good way is to approach some of these manufacturing companies and look at how this new, it's called industry 4.0 by some people, it's called industrial internet with some people. So combining industrial internet, which is internet of things applied in manufacturing, combine that with uh, machine learning and driving a preventive approach to maintenance, driving a data driven approach to maintenance is a very huge industry. Similarly, let's take a look at e-commerce systems. E-commerce systems is where I'm sure all of you will be familiar, where if you're shopping on Amazon, you'll be amazingly surprised at the precision with which it's able to throw something at you as a alert or recommend something which is something very much on your top of your mind which you wanted to buy. How is it so precise? It's because they have a battery of machine learning experts sitting at the back creating recommendation engines, looking at historical transactions of people, and then coming up with recommendations for you, which one are the items which are relevant for you, so that it increases the potential for sale and thereby decreases the traversal time for people, and it's a win-win for everyone except one category of people, which is privacy enthusiasts. A lot of privacy enthusiasts are worried about whether my shopping cart is being monitored, they are monitoring my habits. But I guess a lot of section of the people don't mind because they are looking at using that to get better experience. The next one is web scale analytics. Web scale analytics is basically a huge area for especially large websites like the Amazons or large corporates whose websites, they use a lot of logging mechanism to log all kinds of visitors to the site, log all kinds of traversal patterns on the site. Pattern they do capture the traversals, but what are the use of it? The most important use of it is what is known as digital marketing. Digital marketing today is a field by itself. As I said, marketing as a field is getting up thoroughly transformed by digital interventions where they look at all your logs and come up with interesting analytics on, okay, where were the shopping cart dropped, where were they stopped, what kind of items were dropped, or in terms of traversal patterns, is there a specific path which is causing people to drop, do we need to re-explore the navigation, how you change it, or what is the country from where I'm getting maximum hits for this, why should I target more specific products for this specific target. So there's several use cases, or what is the place where I'm getting log indicating denial of access to the site. Is it because of some permissions or some image not being present or some permissions locally or some problem in the site, etc. So web scale analytics is a very important thing. In fact, moving beyond web, I'm sure Google, Facebook, Twitter, all of them are using massive analytics of all the data that's being generated on their platform to direct ads to you, direct sponsored tweets, direct campaign management related entries to target. So web scale analytics is very useful for several scenarios, whether it is for maintenance of the website, whether it is for digital marketing, or for improving the ergonomics of the website, etc. Customer insights, again, I already covered customer insights coming from recommendation engines, like understanding what kind of purchase behavior or the purchase behavior of customers, or it could even be customer insights like identifying cross-selling, upselling opportunities in financial services. Suppose you are a specific kind of investor who is very much interested in high-risk instruments. Suppose there's a new kind of equity-oriented fund which is launched, you want to push or upsell this to a specific customer. So customer insights is typically driven in all of this by thorough machine learning of historical data. It could be historical browsing pattern, historical transactional data, or historical buying behavior or historical trading behavior. In several other scenarios, it could be just plain analysis of aggregated views of customers also, like segmentation, like geographical analysis or market analysis with respect to specific products. It may not be specifically from customer, but analysis of which kind of item sells in which geography better, or which are the kind of days of the week where there's some kind of sales occur better, or in a discount offering, where should I offer what discount? Where should I place my objects in my retail store for maximum sale? Or in case of a online sale, what time of the day should I give what kind of discount? Suppose you're talking about a Boxing Day discount, right? Boxing Day discount typically is about identifying how to get rid of excess inventory. But then you also want to maximize so that even your what we call as the long tail gets sold. Long tail is about the ones which are few in number, large number of variety, but even those need to get sold along with some of the very popular devices. So customer insights can be a huge variety. It's a huge field by in itself. Digital marketing is one consume example. Better ergonomics, etc. of the digital consumer traversing websites is another example. How do you redesign your website for specific customer? Then another interesting application of customer insights is what we call as trade promotions. Trade promotions is about what kind of products, what kind of discounts should be pushed to what kind of customer in what kind of location. If you see, there are so many what's, but that's where this whole trade promotion optimization experts use historical data to drive machine learning driven models, whereby they very do extremely sensitive analysis of very specialized models, identifying customer, combination with geography, combined with category of products, etc. And they place appropriate marketing budgets based on that. Fraud detection across industry, whether it is banking, whether it's insurance, whether it is retail, looking at historical, here again, important thing is velocity is very important. You cannot wait for days after, say, a credit card transaction has happened, because it's very important for you to clearly, identify whether some transaction has been done by a stolen credit card, not your own card, or somebody who has skimmed your card and done this transaction. So if you see, typically, if you haven't informed your company which is giving you credit card when you're moving out of the country, you typically may get a denial of the transaction because the company has detected that you're doing this outside your typical country where you reside in, and they may want to flag it off as a fraud. So to avoid that, you may have to priorly intimate the bank that you're going to go out of the country, allow such transactions to happen. Or in some cases, you may even just be given a call directly from the center, like in American Express, saying that looks like you have committed this kind of transaction from this country. Did you do it, or you? It could be an email, it could be a phone. So fraud is a very important element. Fraud detection is very important from a government perspective also, especially if you're looking at historical transactions related to the stock holding, directorships, etc. of business leaders. There is a huge stress from a corporate governance perspective in order to improve adherence to government norms. And as you're aware of the several scenarios in the recent past where there have been huge corporate frauds involving heavy ticket directors doing a lot of insider trading or all kinds of misuse of the position. So fraud need not be at very micro transaction level like a credit card, it could be even at a highest level of corporate governance. So fraud detection is very important. All of that is done by appropriate analytics done on historical data. Software analytics is what I'm trying to also come up with a new area, which is basically trying to look at how you can use the historical data of bugs, testing effort, developers, looking at issue tracking systems, looking at check-in information, code-related diagnostics, all kinds of information can be used to improve testing, improve quality of the software, reducing time to market for giving a new version, or all kinds of important areas we can do in using data-driven approach to maintaining software or developing new software or testing software. So there's a new whole area you can look up. It's called mining software repositories. This is basically being used increasingly in IT companies to avoid doing everything based on a reactive mode. Means classical approach to maintenance is when there is a bug reported, they'll go and address it, or when there is a trouble ticket raised, or when there is an incident raised, you go and address it by giving it to a person, assigning it. He'll go and go through the code, look at code base, understand where it is, resolve it, check it in. That's a classical. Now we're moving to just like what we did in manufacturing, using data, how we can take a preventive approach to this by using all the data which is available and applying software analytics to move the paradigm from reactive to preventive maintenance. IT service automation is a great new trend, whereas as Raja was giving example of using OCR recognition to classify a document. Earlier today, this kind of service was given to a person. Today, there were more and more people deployed in doing a lot of menial tasks. In the BPO industry, it's about taking form, filling it by looking at the data in a printed invoice, or looking at a resume and doing classification by hand, saying that this is for this position, this is for that position, or people who do marketing analytics by hand by looking at the data related to the person who has carried out transaction and trying to sell him by trying to do a manual correlation, or people who do voice BPO, they get the data connected and then they look up that and then feed data manually based on interaction. All kinds of things which were very people driven are now being threatened by use of machine learning, which is going to, if not remove the human agent, at least remove the effort by maybe up to 30 to 40%, in some cases up to 70%. In some cases, maybe even 100%. So today there are machine learning systems available which can do some of these tasks practically 100% as good as a human being. Same thing in the IT infrastructure management, looking at some of the tickets like resetting a specific server or configuring certain parameter to a certain value, which is typically done every day, or running a specific backup script, which is a typically running script. Every day morning you come and do running backup script. All of this is not necessarily always needing a human intelligence. People are looking at increasing more and more application of machine learning in remote infrastructure management and BPO industry. In fact, people are also looking at combining software analytics and service automation in maintenance also, where some of the very low hanging fruits of maintenance can be handled by